Unit 5, Similarity, Lesson 4, Parts of Similar Triangles. Your objectives for this lesson are to identify special segments of triangles, to use special segments of similar triangles to solve problems, and to apply the triangle angle bisector theorem. Okay, and just to warn you up front, there is a lot of information in this lesson, so just do the best that you can to keep up with it. Okay, so our first new term here is the altitude of a triangle. You may know this kind of like the height of a triangle. So the altitude is a segment from a vertex to the line containing the opposite side meeting at a right angle. So just to draw you a quick sketch here before we look at the more complicated ones below, if we have, a triangle such as this one, the altitude will go from the vertex to the opposite side, so that's down here, but it's going to meet that opposite side at a right angle. So in this case, that's pretty easy, that's the height. Sometimes though, an altitude will be outside of a triangle, so like right here. If I try to connect this vertex to the opposite side inside the triangle, it's not going to be a right angle. So I'm actually going to have to draw that altitude outside. And that's why this says not the opposite side, but the line containing the opposite side. So that would be like right there. This is the altitude. Okay, and every triangle has 3 altitudes. They meet at the orthocenter. So you can see here I have triangle ABC, that's in pink, and I have my 3 altitudes, 1, 2, 3. So from A to here, B to here, and C to here. And this point that I'm going to put in green is the orthocenter. Okay. And that orthocenter is inside the triangle. Okay. In this example here, we have triangle ABC again, and my 3 altitudes, which meet, well, and I can highlight them actually. So this is 1 altitude, and a 2nd altitude, and the 3rd one. And you can see that they meet right here. This is the orthocenter. Okay. Next, angle bisector of a triangle. So we've already talked about angle bisectors. You should know that this is any segment, ray, or line that divides an angle into 2 congruent angles. So divides into 2 equal parts. The 3 angle bisectors of a triangle all meet at a point called the incenter. So you can see these 2 angles are congruent, these 2 are congruent, and these 2 are congruent. So 1 stripe, 2 stripe, 3 stripes. They meet right here. This point is called the incenter. The incenter will always be inside of the triangle. Last segment, we have the median of a triangle. So the median, we've actually talked about this also before. It connects a vertex of a triangle to the midpoint of the other side. Oh, sorry, no, we talked about the mid-segment. This is the median. So it connects a vertex to the midpoint of the other side. You can see median, middle, midpoint. So those go together. The 3 medians of a triangle intersect at the centroid, and the centroid is located 2/3 of the distance from a vertex to the midpoint of the side opposite the vertex on a median. So that's a lot of stuff there. We have our 3 medians. You see that point F is the midpoint of BC. E is the midpoint of AC, and D is the midpoint of BD. So I can actually mark that like this. I tick marks. 1 stripe, 2 stripe, 3 stripes. And I see E and B are connected right here. This is a median. A and F, that's a median, and CD is a median. This point in the middle is called the centroid. Okay, and that 2/3 business means that maybe DC is 6 units long. So if DC is 6 units, well, 2/3 of 6 is 4. So from the vertex to the centroid, we are going to have 4 units. And then the centroid to the midpoint will have 2. So that's all that's saying. Okay, so this is what we're actually looking at in this lesson here. When 2 triangles are similar, corresponding altitudes, angle bisectors, and medians, so those are the 3 things that we just saw the definitions for, are proportional to the corresponding sides. Okay, so this is important. Example 1. In the figure below, triangle ABC is similar to triangle XYZ with angle bisectors as shown. So you can see angle ABD and DBC both have 1 stripe, as do XYW and WYZ. So those angles are all the same. And we want to find X. Okay, well, since we've just established that the altitudes, angle bisectors, and medians are proportional to the corresponding sides, we can set up a proportion. So I can say here 24 over X, 24 and X, equal 10 over 8, because I have 2 segments here, so for my angle bisectors, and I have the side lengths, so I have my proportion. Now we can cross multiply, and we get 24 times 8 equals 10x, and we can divide by 10. So 24 times 8 over 10 is x. Well, let's figure out what this is. Okay, so this is 19.2. So x is 19.2. Okay, the triangle angle bisector theorem. An angle bisector in a triangle separates the opposite sides into 2 segments that are proportional to the lengths of the other 2 sides. Okay, let's take a look at what this means. Example 2, find x. Okay, so I see right here I have 2 equal angles, RSU and UST. That means that SU is an angle bisector. So segment SU is an angle bisector. Okay, which means that these 2 segments here that are separated by SU are proportional to these other sides. So I can set up my proportion, x over 20 equals, which number goes with x? 15 goes with x. They're both on the same side of SU. So 15 over 30 must go with 20. I'm going to cross multiply, and I get 30x equals 20 times 15. So 20 times 15 is 300. I'm going to divide by 30. And I get x equals 10. And that wraps up this lesson. Remember your 3 special segments that you learned, which were medians, angle bisectors, and altitudes, and how they separate triangles into proportional parts.